All right, so let's see how much you guys remember from the Desmos activity. All right, so if you have a number multiplied by sine of an angle or cosine or sine of theta or cosine of theta, it does create a little circle. Sometimes it circles to the right or left, sometimes it's above or below. But this number that you're multiplying it by, what does that give you? What part of the circle did that give you? Yes, that's the diameter. All right, we're going to divide this box into two sections. All right, so the one with cosine, that's the one that's either to the left or right of what we normally consider the y-axis. It's not technically the y-axis. So if that a for the cosine is a positive number, then it's going to be graphed to the right of theta equals pi over 2, which is what in rectangular, we keep that correct. We have one more person coming in. In rectangular system, that's what we call the y-axis. That's going to be the last time I use that because I don't want to think about x and y. I want to think about r and theta today. And then if that a is negative, it's going to be graphed to the left of theta equals pi over 2. And then all of these graphs are symmetric. The ones with cosine have polar axis symmetry. And the polar axis, if we're thinking about rectangular coordinates, is normally what you would think of as the x-axis. But since we don't have x's and y's, it's called the polar axis. So if you folded it or flipped it on that axis, the circle would flip right on top of itself. All right, and then the ones that sine, they're the ones that are graphed up or down. So if A is positive on the sine circle, then it's going to be graphed above the polar axis. Or what we would normally consider the x-axis. So a little circle up there. If that A is negative, it's going to be below the polar axis. And any of these graphs, it's a sine graph, it's going to have theta equals pi over 2 symmetry. Or what you would normally consider y-axis. So if you fold it on that line, it's going to fold on top of itself. All right, and then if theta is multiplied by a number, it creates a totally different graph. It creates a rose or a flower graph. It's called a rose. So on this, we're going to not go all the way down in our division because there's something we're going to write that is the case for both graphs. All right, so on the original circle, that A was the diameter. Do you guys know what A is on the roses? It's okay. It's the length of the petal. Length of each petal, I should say. All right. So just like the circle that had cosine, the rose that has cosine has polar axis symmetry. And sometimes that's a way you can decide if it is a rose with a sine or a rose with a cosine. But some roses have multiple symmetries. So Another way you can figure out which is which is on the cosine graph. The first petal is at the angle theta equals 0. So it's going to be on the polar axis. So the cosine one, the petal could look like that, the first petal, or technically the first petal could look like that for cosine. For sine, it's always going to be the first petal is like at an angle. A sine rose is not going to go on the polar axis. All right, so that's something like for me to decide which is which. I look at that petal, that first petal. All right, and then the sine graphs have theta equals pi over 2 symmetry. And the first petal is at, now this one changes from problem to problem. So to figure out the angle the first petal is at, it's theta equals pi over 2n. Okay, and then do you guys remember what determines the number of petals? N determines the number of petals. Sometimes it's n, sometimes it's twice as n. I said that weird. But when is it just n? When n is odd. So if n is odd, there's n petals. If n is even, there's 2n petals. Right. So example 1 and 2, we're going to be doing a couple of graphs. Example 1 is going to go really, really fast. Example 2 is going to be extremely tedious. What is the graph of example 1 going to be? A circle or a rose? Circle. So if theta doesn't have a coefficient other than 1, it's a circle. What's the diameter of our circle going to be? 6. And then is this circle going to be left, right, up, down? It's going to be left. So what we'll do from it's called the pole, the origin technically is called the pole. We're going to go 6 circles out. Okay. And then we're going to try our best to draw a circle that has that diameter. Oh, that's actually better in my last class. It's pretty easy. Now, we could have plugged in points and found their polar coordinates like we're going to do on the next one. It's just not necessary on a circle. Okay, the next one is going to be a rose because we have that 3 multiplied by the theta. So for A, we're just going to write down all the things that we can tell about the graph. So how many petals is this graph going to have? 3 petals. How long are they going to be? Yes, 3 petals of length 7 plus 0. All right, and I know my first petal is at that angle. Now for sine, we take pi and divide it by 2 times whatever n is. N in this case is 3. So it's going to be at the angle pi over 6. Now I don't want you to graph this yet because I really want to focus on the order that things get graphed because that's important for our standards. But I know this first petal is going to go through this point. So the first petal is going to be, I drew it in the wrong order. Actually, it's going to be like that. But we'll get to that in a second. Now, one thing that's not on this sheet that was on the Desmos activity is the angle between the petals. Do y'all remember how to do that? Number of petals, yes. So the angle between is going to be 2 pi divided by the number of petals, which not 6, is 3. Okay, So we could kind of visualize what this rose looks like, but we're going to get a bunch of points, like, I don't know, 14 points or 13 points. All right, I'm going to do some of these with you, and then I have these cards for you guys to do one on your own that will collaborate to get all the points on the graph, because this is very tedious to figure out. All right, so what we're going to do is we're going to take each one of these angles, or I'm going to do 4 and you guys are going to do 1. We're going to plug the theta into the function. Now, one thing that the Desmos activity asked you to do is which was the independent and dependent variable, and you didn't really know because you hadn't done a lot with these graphs yet. But we know that now we're going to plug in a theta, which is 0 in the first one, and then it's going to give us the r. So theta is the independent variable, r is the dependent variable. All right, and you're going to want to either have the unit circle memorized or have your unit circle out. So what is, 3 times 0 obviously is 0. What is the sign of 0? It would be the y value there. It would be 0. So 3 times 0 is 0. So that's our first point. All right. The next one, I'm going to do pi over 12. So I'm putting pi over 12 in for theta. Okay, so we have to do some reducing on this one. So if I have a 3 in the numerator and a 12 in the denominator, how do you think that's going to reduce? 1/4, or 4 in the denominator. So it's going to be pi over 4. All right, what is the sign of pi over 4? Yes, so this becomes 7 square root of 2 over 2. I will tell you what that equals in just a second. So like I said, a lot of these questions are on the non-calculator. I don't think this is something you're going to be required to do 7 times the square root of 2 over 2 without a calculator. So I'm going to tell you what it is. It is almost 5. So it is approximately 4.95. All right, we're going to skip all the way down to 7 pi over 12. So we have that same situation where we have 3 in the numerator and 12 in the denominator. That's going to reduce to 4 in the denominator. So it would be 7 pi over 4. So the sign of 7 pi over 4 should be similar to the sign of pi over 4, but we have to know if it's positive or negative. Is this one going to be positive or negative? You can look at your unit circle if you have it. The sign of 7 pi over 4, what is that? Negative square root of 2 over 2. So this is going to be negative 4.95, or almost 5. Okay, because we're doing 7 pi over 12. 3 over 12 reduces to 4 in the denominator, and that 7 is still up there. All right, one more. Let's do 5 pi over 6. Okay, so this time we have 3 over 6. What should that reduce to? Yeah, it's a 2 in the denominator, so this becomes 5 pi over 2. Now that is not going to be on your unit circle. So any angle bigger than 2 pi is not going to be on there. But this one has a angle called a coterminal angle. That's a totally different angle, but it has the same sign. So do you guys remember? It's been a while. Do you remember what you do to find coterminal angles? You're just going to subtract 2 pi from it. So I'm I'm going to go down into another area. So we would do 5 pi over 2 minus 2 pi because it's too big to be on our unit circle. So we find its coterminal angle. So 2 pi with a common denominator of 2 is going to be 4 pi over 2. So the coterminal angle is pi over 2. So in the place of 5 pi over 2, I can find the sine of pi over 2. Different angles, but they have the exact same sign because they're coterminal. Okay, so what is the sine of pi over 2? Should be 1, so this is going to be 7. Okay, so I'm about to give you an angle, and you're going to plug it in to 7 sine of 3 theta, and you're either going to get 0, you're going to get positive or negative 4.95, or you're going to get positive or negative 7. There'll be no other answers to these questions. 0, positive, negative 4.5, or positive and negative 7. Some of these are going to be more difficult than others. So some of them, you'll have to do what I did in that last one, is subtract 2 pi. Some of them you won't. So if you get done way before someone else, it's okay. Because if you get 1, you can multiply by 7. All right, find your angle. I'm going to depend on you to give me an answer so we can fill in the charts. All right, y'all ready? Who had pi over 6? What'd you get? 7. That's right. Pi over 4?
-4.
Did you get negative? I think it's positive. Yeah, it's positive. It's okay. Pi over 3?
0.
Yes. 5 pi over 12? Yes. Yeah, some people had more than one person with the angle. It's okay. Pi over 2? It should be negative 7. So the sine of 3 pi over 2 is negative 1. And then negative 1 times 3 is negative 7. All right, 2 pi over 3? Yes. Good. 3 pi over 4? should be positive 4.95. 11 pi over 12, positive 4.95. It's okay. And then pi,
0.
good job. All right, so everyone fill in your table if you haven't already, and then we're going to plot these points. It's going to take forever. It's okay. All right, so any of these points where the r is 0, it is going to be at the pole. What's wrong? You okay? Which one? What was the original one? What was the original theta? 3 pi over 4? Okay, so you get 9 pi over 4. And then whenever that's too big, so you do 9 pi over 4 minus 2 pi, which is 8 pi over 4. And that gives you pi over 4. And the sine of pi over 4 is positive. So this is subtracting 2 pi, like I did right here. So when you subtract the 2 pi from 9 pi over 4, you get positive pi over 4. All right, it's okay. All right, so we're going to start with 0, 0, basically, which is going to be at the pole. So any of these where r is 0 means there's no radius. It hasn't moved away from the middle, so it's going to be at 0. All right, our next point is going to be at pi over 12, and then the r is going to be almost 5. So you might as well just graph it at 5. It's so close, it's fine. All right, and then the angle is pi over 6, and the r is 7. So we kind of knew that pedal was going to look like that. And then at pi over 4, we have our almost 5 again. And then again, anytime the r is 0, we're going back to the 0 point because there is no radius. It hasn't moved away. All right, and then we're going to do 3 that are going to be more difficult because the r's are negative. All right, so we're going to go to negative 5. Might have went out too far. And then we're going to rotate the angle. That's 5 pi over 12, which is this angle. So it's going to take us to a pi over 12. It's going to take us to that point right there. All right, and then we'll go to negative 7 and rotate pi over 4. Sorry, pi over 2. Just going to take us there. And then negative 5 again and rotate 7 pi over 12, which should take us to that one. So even when there's a negative rotation, it'll still take you to an angle that has that same denominator. That helps me kind of see it all. All right, and then we go back to 0 again. All right, and then the rest of them are all positive, which is great. So at 3 pi over 4, we have the almost 5. I have a hard time counting. 5 pi over 6, we have the 7. And 11 pi over 12, we have the 4.95. Okay, so don't connect them yet. You can, but I want you to watch me connect them because one of the really important standards is that you know the order that this rose is drawn. And so it's drawn in the same order we graph the point. So we start, you can just watch me and then connect in a second. So we start in the middle and then we go around for this pedal, swoop down to this pedal, and sorry, I'm getting wobbly, swoop up to that pedal. All right, so connect yours also. You can do a better job than I did. I tried to do it all at once. Now, one great thing about the AP exam is the polar functions are only going to be on the multiple choice. So you're not going to have to do what we just did on the exam. You will have to answer questions about the graph where you'll need to do a few points, or just be able to match it with this equation or match it with the graph. But I needed you to see that to be able to answer some of the questions. But on the free response, you will not have anything polar to draw. All right, so what I just said is basically what that next paragraph says. So on example 3, I want you guys to see how many of those blanks you can fill in by yourself. So this is our graph. See if you can figure out all of those things, please. All right, any questions on that? The only thing we hadn't talked about was the range of the R's, but it should be the positive and negative version of whatever this number is in the front. All right, and then the next one is similar to a question you might see where you have the graph, you have 4 choices for the expression that gives you that polar function, and they all have the same number in front and they all have the same number in front of theta. So you really first need to decide, is this a sine rows or is this a cosine rows? And the way I decide is I look at the polar axis. If there is a petal on the polar axis, is cosine, 100%. The sine flowers never are on the polar axis, so we can mark out the signs. Then we have to decide if this is one where the A is positive for or the A is negative for. If you were just going to guess, what would you guess? Negative. I would guess negative also, because it's on the left. The petal that's on the axis is on the left side. Now, we can't always just trust that because sometimes the petals are like that. They're 2 that are on that axis. So you can just plug in some points and figure out which is which. But if I put in 0, then I'm going to get -4, 0, which is going to -4 and not rotating any. So it's definitely that one. All right, any questions on that? Okay, sometimes you'll have it like that. Sometimes you'll have the equation and you'll have 4 graphs to choose from. And then there's a lot of questions like this one, and it's kind of tedious to figure out. So you have a partial graph. So this is a portion of the polar function f of theta equals -3 sine of theta. And we're trying to figure out what this A and this B are. Like it goes from which angle to which angle. And so this is the first time I've ever taught this. And so I did it so many different ways, trying to decide the best way to show you. I think what's best is to think about what R needs to go from. So I don't really know what order this graph was graphed, but I know my smallest R is either 0 or -3, and then my biggest is the other one. So I know that R needs to go from either 0 to positive or -3 or positive -3 to 0. So this is graph is either graphed this way or graphed this way. So then I just start eliminating answer choices. Sorry, I left out my O on 2. So 0 to positive -3 or positive -3 to 0. So what I would do is I would just do some little tables of values for each of these. All right, so we're trying to decide if it's the portion that goes from 0 to pi over 2. So leave a little space for another point there. On this one, we're trying to decide if the angle goes from pi over 2 to pi. And then we're trying to decide if this is 0 to pi or from pi to 2 pi. All right, so what I'm going to do is I'm going to find the r's that go with these thetas. So I'd start off by putting in 0. Let me do the right color. So I would find the sine of 0, which I hope you guys all know. I would like for you to know sine of 0 is 0, just like off the top of your head really fast. And then I would plug in pi over 2. Right. And then the sine of pi over 2, you can use your unit circle. That's the point that's straight up. The y-coordinate there is 1, so 1 times -3 is -3. So could this be a possible answer for our problem? So if your r either changes from 0 to positive or -3 or the other way around, it's a possibility. So A is a possibility. All right, let's check B. We already know that f of pi over 2 is -3, so I don't need to do that again. All right, the sine of pi is 0, so -3 times 0 is 0. So there's another possibility. All right, on this red one, we already know both of these. We found f of 0 on the first one, and we found f of pi on the second one. Could this be a possibility? No. This went all the way from 0 to 0. So that means it did a full circle. So 0 to 0 is going to be a full circle. So we just want a partial. Bless you. All right, we already did this, 0. Sine of 2 pi is also 0, so this is not going to be a possibility. It is also a full circle. So how are we going to figure out between A and B? Okay, we can try other angles. So you can look at your unit circle, pick out an angle that's between 0 and 2 pi, like pi over 6, and I can plug it in. Oh, I got 2 negatives there. Sine of pi over 6 is 1/2, and then 1/2 times -3 is -1.5. And then just see if this falls on the portion of our graph that we want. That's a little challenging because it is a negative r, but we've practiced quite a bit with these points. Hopefully you're good at it. Okay, so pi over 6 is this angle, and then -1.5 would be right here. So if I took that point and I rotated it this much, is it going to take us to the circle? The half of the circle? It's going to stop right here, which is wrong. So it's not A. So hopefully it's B. Let's just double check by putting in an angle that's between pi over 2 and pi, like 5 pi over 6. Okay, the sine of 5 pi over 6 is 1/2 again. So we're going to get negative 1.5 again. Okay, so I go to the 5 pi over 6 is going to be this angle. So I'll go to the negative 1.5 again. And I'm going to rotate this much. Is it going to take us, bless you, is it going to take us to the circle? It is. This is going to take us right there, which is the right place. So that is the right answer. And believe it or not, I think that's the best way to do these problems, even though it's crazy tedious. Okay, so if I'm graphing this angle or this point, I would go to negative 1.5, which is here, and rotate this much from this point. It's going to take us right there. All right, one more type of problem that I've seen on the practice tests that they really like. So I have the full graph of f of theta equals 3 cosine of 3 theta. But we are going to restrict the domain to this. The portion of the given graph that remains consists of two pieces. One of those pieces is the portion in quadrant 3 that goes from C to D. So we're either talking about something like that, or we're talking about something like that. We don't necessarily know if it's the first portion or if it's the second portion. All right. Which of the following describes the other remaining piece? So it's either going to possibly from D go to that, or it could go to that. Or if it was, no, I think it has to go from D. No, I guess if it went the other way, it could be that one. I don't know. So here we go. I would do a table again. And I would put the restricted angles or the restricted domain in my table just like I did on the last one. And then I would plug in. All right, so what is the cosine of pi? Should be -1, so this would be -3. Okay, so which point does that correspond to? A, B, C, or D? So we go to -3, and then we rotate pi over 3. It's definitely not D. I'll go ahead and tell you that. That's going to be C. All right, halfway between these two angles should be, when we plug it in, it should give us D unless we messed up on that first part. So what's halfway between pi over 3 and 2 pi over 3? Look at your unit circle if you don't know. Pi over 2. All right, so if I plug in pi over 2, I should get point D unless something messed up. All right, the cosine of 3 pi over 2 is 0. 0 times 3 is 0. Anytime R is 0, it's going to be at the middle, at the pole. So that is D. All right, so that's the first piece from C to D. All right, let's see what happens with 2 pi over 3. The cosine of 2 pi is 1. That's going to be 3. All right, so out of A or B, which one is at the R is 3 and the theta is 2 pi over 3? Oh, that says 6. They messed up on this graph. Sorry. That is good. That should be A. I just now noticed that. This should have been 6. It's fine. We'll say that's 3. 1, 2, 3. Sorry. I just noticed that and I've looked at this problem a lot. Okay. So the second piece went from D to A. So what do you guys think the answer is? C. Okay. So because